Welcome to the deep dive, where we zoom out on these massive architectural shifts happening in tech and try to figure out, which lessons we should actually be applying and maybe which ones we should be running from. We have a genuinely fascinating premise today. We're going to look at the biggest movement of the last decade, microservices, to try and understand the trajectory of the biggest movement happening right now, agentic AI.
It really is an exercise in pattern recognition. We're looking at some source material, a reflection that was, I think, initially prompted by a pretty skeptical article about microservices.
Okay.
And it draws this quiet but really critical parallel between these two enormous shifts in how we build and govern complex systems.
Okay, let's unpack this. So the core idea, and it's a provocative one, is that all this immense excitement, this rush to adopt agentic AI, and even the potential backlash that could come later.
Right.
It might just be mirroring the exact path we saw with microservices, a decade ago? It's like a cycle of architectural zealotry.
And our mission here isn't to diminish the power of AI agents. I mean, they're obviously transformative, genuinely. But history teaches us that architectural scale, it always has hidden costs.
Holy!
We need to look past the promise of, infinite autonomy and really assess the practical trade-offs now.
Right.
Before we replace one kind of hidden complexity, one we sort of understand, even if it's messy, with a brand new and often totally opaque form of autonomous complexity.
So let's start with that history lesson then, because you can't really talk about complexity without talking about the monolith. Microservices, they really began as this ideological rebellion.
Rebellion against this single giant intertwined system. Exactly. The monolith was the enemy.
Right, because any change, no matter how small it was, it felt like this high-stakes, system-wide risk.
Completely. The systems were so coupled that deploying anything became this massive logistical nightmare. The whole promise of microservices was, freedom. Agility. Break that huge system into small, independent pieces.
And each piece could be owned by a small team.
A small team, deployed on its own schedule, evolving at its own pace. It was a genuine liberation movement for developers.
And for a while, it really did seem to work. Velocity went up, but that's where this subtle shift happened that our source material really cautions us about. The complexity, it didn't just vanish when the monolith was split apart.
No, it didn't disappear. It just... It changed its address.
Changed its address. I like that.
It became a distributed complexity. So teams stopped managing one system, and all of a sudden they were managing hundreds. And that instantly introduced this massive operational overhead that most architects, frankly, they just underestimated.
And think about the specific technical headaches that came with that. It wasn't just about monitoring anymore. It was, distributed transactions.
Oh, that's a huge one. Just ensuring consistency across dozens of services when a single business operation spans all of them.
That's the critical detail right there. It went from being a problem of, say, a monolithic code structure to a problem of coordination and network reliability. Suddenly, you needed these elaborate service meshes just to handle internal communication.
And robust circuit breakers to stop one small failure from cascading through the whole system.
And then trying to figure out where a request actually died, that required sophisticated distributed tracing.
The complexity didn't live in the application code anymore. It moved. It lived in the infrastructure and in this whole new governance layer that you needed just to stitch everything back together.
So the core lesson was that microservices, when they were adopted like a dogma, they just traded structural complexity for operational complexity. People were mistaking fragmentation for true flexibility, and that operational cost often just wiped out the initial gains.
That really sets the perfect stage for the dilemma we're in now. If microservices was the great unbundling of code, splitting functions into separate components, we are now living through the next unbundling. And this time, we're not just splitting the code. We're giving those components something totally new. We're giving them judgment.
That is the architectural shift toward agentic AI. So if microservices are, let's say, tools, bits of code that do a specific, predictable thing, then these agentic AI systems are more like coworkers.
Or specialized contractors, That's a great way to think about it. Because they bring judgment, reasoning, and Fundamentally, they bring initiative based on how they interpret things.
And we are seeing this architectural transition just speeding up, especially in places like agentic commerce, large-scale retail, where the complexity is already astronomical with supply chains and real-time pricing and everything else.
Indeed. And the source material highlights some really specific operational examples. We're talking about agents being deployed as, say, inventory balancers.
So they don't just report the inventory level.
No. They actively negotiate stock transfers based on predicted demand and supply chain latency. Or we see audience intelligence engines that interpret raw market data to build, optimal media strategies on the fly. Competitive intelligence bots that are actively engaged in real-time price matching.
But the example that really defines this whole shift for me is the end-to-end shopper agent. This thing isn't just recommending a product. It's taking a customer shopping list, it's applying constraints like budget or substitution preferences or delivery time, and it's assembling the entire basket.
And negotiating substitutions if something runs out of stock, and then autonomously completing the whole transaction.
That capability right there, that's the whole shift. Agents are moving way beyond just exposing functions through an API. They handle full, non-deterministic workflows.
They manage constraints that are changing moment to moment, and what they deliver are outcomes. And because this functionality, just having a smart helper, it feels so natural, the architectural choice to use it often just flies under the radar.
It feels inevitable.
It feels inevitable, which is the exact thing we need to be questioning.
Okay, so let's introduce some of that friction then. Back in the microservices era, when modernization was the goal, the most successful strategy against the monolith was often this surround and choke idea.
Right. You wrap the old system in new modern services, and you slowly shift the workload over until the monolith just withers away.
So how does adding autonomous agents to the mix enhance that strategy? And more importantly, what new risks does it hide?
Well, Surround and Choke was so successful because it was non-disruptive. You didn't have to go in and rewrite all that old, complex business logic.
Yeah.
With agents, that strategy gets an unprecedented amount of power.
Because they don't need a clean API from the legacy system.
They don't need a clean API at all. They can talk to the old system just like a human would.
Wow.
They can sit on top of these complex, imperfect legacy systems. They can read human-readable reports or interact with, archaic terminal interfaces. They mimic human input. They interpret the chaos that comes back, and they just intelligently start taking over workflows.
So this isn't modernization by the old method, by deconstruction, where you meticulously rewrite and rip out code.
No, it's modernization by accretion. You're growing these smart, adaptable layers around the existing stack.
That sounds incredibly appealing, very low friction. But this is where that skeptical lesson from the microservices era really hits hard, isn't it? We have to be radically honest about the trade-off.
We do.
In moving to agents, we are trading predictable code paths for autonomous, non-deterministic behavior.
And that transformation of complexity is where the great danger lies. We understand how a microservice fails. It's deterministic.
Right.
If service A gets some corrupt data from service B, it throws an error. We get stack trace, we have a clear source of the failure, and we can apply some retry logic or fix the data contract. It's a known problem.
But an agent fails in a totally different way. It's more of a cognitive failure, not a technical one.
That is the key distinction. A microservice might mishandle data and timeout. An agent might misinterpret the data. Or even worse, it could hallucinate a course of action because its prompt chain drifted just a little bit off course.
So going back to that shopper agent we were talking about,
Yeah.
What if it misinterprets a constraint about budget?
Exactly. Imagine it decides, autonomously, to substitute a $10 item with a $50 luxury substitute.
Oh, wow.
Just because it decided to weigh delivery speed too heavily in its internal reasoning.
And the technical system hasn't crashed. Nothing's broken. But the business outcome is just completely wrong.
It's wrong, and the root cause, that internal chain of reasoning, is totally opaque. You can't even reproduce it. The financial impact of that kind of subtle, systemic cognitive drift could be catastrophic in large-scale commerce.
Debugging that sounds like a nightmare. You're not looking for a break in the code anymore. You're looking for a flaw in its judgment or in the data it was grounded on.
Right, and this introduces huge new challenges for coordination, especially when agents start negotiating with other agents. It can lead to these complex, surprising, and very often expensive unintended consequences.
It also kind of explains why these ideas become fashion. Microservices resonated with people because they felt clean, they were modular, they promised a sense of intellectual control over all this sprawling software.
And agents resonate because they feel alive. They promise relief from this relentless data overload, from the fact that our legacy systems just can't adapt fast enough. They feel fast, adaptable,
Yeah.
inevitable.
But as we learned with microservices, when an architecture becomes dogma, engineers often stop asking the most important question, is it the right tool for this specific job? So if we need to avoid falling into that dogma trap all over again, what does a sustainable, grounded approach to agentic AI actually look like? It can't just be a mandate to rip and replace everything.
Absolutely not. The most sustainable view is to see agentic AI not as the successor to everything we've built, but as a sophisticated autonomous layer that complements the existing stack. We have to be incredibly disciplined about where autonomy gives us a real measurable payoff versus where predictable execution has to remain king.
So that means a true hybrid model. We rely on the established predictability of deterministic systems where we need that rigor.
Right.
And we only deploy agents where that adaptability and interpretation are actually critical.
Precisely. Your core transactional systems, the financial ledger, the inventory master, the user auth databases, they have to remain the bedrock. The APIs and the modular components, they're the reliable, predictable connective tissue.
And the agents.
The agents serve as the nervous system. They sense complex inputs, they interpret ambiguous data, and they act on that interpretation, but only within the boundaries that are set by that connective tissue.
So if we just treat agents as smart microservices, we're setting ourselves up to fail. Because this new paradigm, it demands specific, really rigorous new operational practices to account for all this non-deterministic behavior.
It does.
So what do those essential new practices look like for a team trying to deploy this kind of hybrid architecture?
Okay, this is where the rubber really meets the road for anyone listening. First, you need rigorous and careful scope definition. And I don't just mean defining what an agent does. I mean defining its state machine, its permissible tools, so what APIs it's allowed to call, and crucially, its action budget.
Its budget, you mean like financially?
Exactly. If an agent can transact financially, its budget has to be strictly capped, and just as important, completely observable in real time.
So you're enforcing hard boundaries on its autonomy. Okay, so what about tracing those cognitive failures you mentioned earlier? How do we do that?
That brings us to the second practice. Enhanced, rigorous observability. Standard logging just won't cut it. We need to be able to track the agent's internal reasoning path, the whole prompt chain that led to a specific action, and we need to detect judgment drift over time.
So if an agent starts, I don't know, routinely making substitutions that lose the company money,
we need to be able to trace back to exactly when and why it changed its internal weighting for that decision.
that sounds like a huge amount of work, a huge burden. If the whole point of agents is speed, isn't this high degree of vigilance just going to slow us down and add more overhead?
That is the necessary trade-off. You accept the complexity of governance in exchange for speed and adaptability. And this leads to the third practice, which is mandatory human-in-the-loop governance.
A human gate.
A human gate. For high-stakes actions, any change that results in a permanent financial transaction or modifies a critical business rule, there has to be a human to approve it. Autonomy requires oversight. It's not just deploy and forget.
And what about the connection itself? The layer between the predictable core and the unpredictable agent?
That's the fourth practice. Clear, enforceable data contracts. We cannot allow agents to rely on messy, raw outputs from LLMs for critical system interactions. They have to interface with the core systems using structured, versioned APIs.
So even if the agent's reasoning is a little fuzzy on the inside,
the language it uses to talk to the reliable parts of the system has to be strict and unambiguous.
That really shifts the focus. It's not about assuming autonomy just eliminates complexity. It's about a central mandate. Understanding that autonomy doesn't eliminate complexity, it transforms it into something that demands this new specialized kind of vigilance.
The transformation requires new skills, new tooling, and frankly, a whole new mindset.
So if we step all the way back and summarize the core lesson we've taken from drawing this parallel from the microservices era to the dawn of agentic AI, it seems to be that architectural movements, they too often turn into dogma. The danger isn't the technology itself, it's the zealotry that turns a brilliant solution into a mandatory default. And that blinds us to the real costs.
It's about mindfulness over momentum. We can't let the excitement, this feeling of our software coming alive, blind us to these necessary trade-offs. We learned the hard way with microservices that replacing a complex monolith with a sprawling, opaque web of services often just made things worse.
Right.
We cannot afford to now replace that sprawl with the hidden complexity of autonomous, unpredictable behavior without having these rigorous new guardrails in place.
And as we see this new hybrid architecture forming across industries, it's not about replacing the old. It's about strategically growing around it, using that autonomous layer to interpret the world just faster.
So a final thought for you to take away. As you look at your own organization or your industry, really consider the processes you manage. What task? What task truly requires the unpredictable, adaptive, and autonomous power of an agent? And which task absolutely must remain grounded in the predictable modular components that we already know how to manage and debug effectively? The key is asking, where is that promise of transformation truly worth the necessary increase in governance complexity? I think that honest assessment, that's where the future of grounded engineering really lies.